Good morning, thank you for joining me again for another bit repairs video. This is a battery stuck on 1% on an iPhone 8, this repair. I wasn't going to do a video this morning because I haven't got that long. I've literally only got until the shop opens at 9 o'clock. So let's see if we can try and get this board fixed before 9 o'clock. So what we have is, let me go to camera 1, over here. This is our board. Focus. There we are. No, you're not going to focus, are you? There we are. So this is our board. It is an iPhone 8. So, whoa, that's gone well out, that has. And straight back in again. So I wish I knew how to sort this camera out. I really need to read some instructions. So yeah, this is an iPhone 8, and from these pictures you really can't see that it's got any issues. It's everything's far too small on there. However, if you have a look under the microscope view, you'll be able to see quite clearly. Let me have a little look so you can see. It's not as clear as it was because I went and gone and stuck a lump of flux. Sorry, that's somebody else's phone alarm that keeps going off, but there's no image on it, so there's absolutely no way I can switch it off without taking it apart. Should have fixed that one first, shouldn't I? I'll wait for a little bit. I'll actually take the base screws out of this phone that keeps going off, and then hopefully disconnect the battery, so at least that won't keep going off all the time. So on the picture that you can see here anyway, you can see I've stuck a lump of flux over that area there. So let's just get this screen up. That was where I was due to start doing the repair, and then I thought, no, let me get some people on board and see if anyone wants to join me for this repair. So hold on a sec, nearly finished doing this one. Literally, I've got a couple more screws to take out. There we are. That's that shield off, and then battery unplugged. Right, that's not going to be interfering with us much longer. So, here we are again then. Let's have a look at this board. Let me just melt off this flux a little bit with my soldering iron, and then you'll be able to see what I was talking about. So, the problem we've got here is, so there's, right, if you have a look here, you can see there's one pad there, which is great, we can use that one. Then we've got the MOSFET here, this little MOSFET, that's absolutely fine by the looks of things. But then you'll notice that there's two pads missing next to it where the other MOSFET is supposed to go. So we know from past experience that these MOSFETs are required in order for the battery percentage to be displayed correctly. If both of these aren't functioning, you will get a battery stuck on 1%. You'll charge it as much as you want, but you'll end up with random reboots. You will end up with error logs which will say TG0B, TG1B in the panic logs, and it's where basically it can't detect the thermal gauges on the battery. So basically it uses these circuits to regulate charging and find out what percentage these batteries are on, what percentage charge these batteries are on. Because it doesn't want to overcharge them, doesn't want to undercharge them, doesn't want to end up in a Samsung situation years ago where they all started exploding in people's pockets. That wouldn't be good. So what we're going to do then is I'm going to bell out this other one. So we're going to go into diode mode, and then I'm just going to test the two terminals on this battery. So I'm going to put my red probe on ground, and then the black probe on this one here. One battery measurement terminal, and I should get around about 740, 750. So that's 751, that one, which is fine. Measure the other one here. Okay, and we're getting open circuit because this one here is supposed to go to this other pin. If I put my ground on there, it should, if I can get deep enough. Should. No, it's just gone too deep inside there. It's just gone too deep inside the metal. So where it's pulled off, it's basically pulled off right from the root inside. Let's just see if I can get a slight measure on it. Wow, it has gone deep, this one has. No. There's no point me digging at the board. I'll end up causing damage to the board if I do that. So there's no way I get into that one. It's proper deep inside the board where that one's split off. So, but anyway, trust me that that particular pin there goes over to the other battery terminal. So that's where that one goes over to. But what about the other one? It's not very common for this other one to come off the board. I find it's very infrequent that this pin here, where I'm pointing at the moment, it's very uncommon for that to come off. This one here comes off all the time. It's very, very common for this one to come off. This one and this one doesn't necessarily come off on a regular basis. Fortunately though, if we look at the schematics, if I go over to camera 4, hold on, camera 4, there we are, you can see from ZXW tools, so here is the one that goes across and over to that pin there, and then this is the other one that's missing. Fortunately, we've got two components here which we can very easily access, that we can run a small micro jumper round, get a piece of wire ready there for ready when I put the component on. Not as easy as it is with just one, but you know, so be it. What needs to be done needs to be done. So here we basically find that if I can try and get my probe on these two, we should find that this component here goes to there. There we go, it does. Fortunately, it didn't go really deep, that one, so I could easily get access. Can I get this one as well now? I've gouged it out a bit. There you go. See that? Got the angle there now. I gouged it out a little bit before with the scalpel, so it got a bit more connectivity down there, down below in the little socket hole. For some people, occasionally I see people running jumpers out from the hole and putting a little curl on top of it. I'm not sure about that. The reason being is because those little nodules that are left behind are so delicate that it could snap off at any time. So it's just so easy to run one of these jumpers around the side of the battery connector, glue it down a little bit, and then, you know, you're fine. You're guaranteed to have a good connection then. So let's do that anyway. Let's get a bit more flux. Get some flux around the side of the back connector. Gonna move that antenna out the way. I'm doing this in housing, this one. I do usually do this repair in housing. I will change my soldering tip to my new one. I have a tip that's in reserve basically, which is, you'll see on this now why it's kept in reserve. Because if you look at this tip, quite expensive, these tips, but you'll notice just how sharp this tip actually is. So let me switch back over to camera 3, microscope view, and you'll be able to see then just how sharp this tip here is. There you go. So hopefully you can see that. It's absolutely tiny. These are the JBC tips, these ones, so they're around about 20 odd pound, £30 per tip. But there really is nothing better than it for microsoldering. There's simply no comparison. So we've got two choices here. We could either run coated jumper wire or uncoated jumper wire. So depends on what you've got. I prefer on this one, because it's running quite a long way, I prefer to use my coated jumper wire, which basically is this one, which is in the middle of the camera now. So I'm just going to uncoat a bit at the end of it with the iron. Okay. I'm trying to do this with my fingers at the moment to keep tweezers that out of the way. Okay. So that jumper wire is in and connected. See if you can see that now. You can kind of see it. So the problem is with these things, it's so fucking small. There we go. You should be able to see that's connected now. I can see it on my scope view, so you should be able to see that yourselves. So that's just tacked onto the side. Now what I'm going to do is I'm going to pull it round here over the top of itself. The reason I pull it over the top of itself and not just solder it on the other way round is because it gives it a little bit of strain relief as well. So I'm going to go around and we'll have a little look at where we're going to go with this jumper. We want to make sure it doesn't short out on anything. So I just want to get me tweezers, not tweezers, sorry, scalpel. There we go. Don't have a super sharp one out. You can see I'm not very prepared for this video this morning, can't you? I'll just get another super sharp scalpel. Super sharp. And these are the ones I use for audio mainly. Now you all have seen potentially my audio video, you know how I do it. So you know why I need a super sharp scalpel every single time. So let's just have a look here, and I am going to route this round here. Okay, round there. I'm going to route it round the side of these components here, so that it doesn't short out on them components at a later date. Obviously, I am going to add some underfill to this as well. So I'm just going to chop that off there. Now I know it's long enough. Okay, so that one chopped off. Then what I'm going to do is I'm going to pull it over here, and I'm just going to get the end and I'm going to rub off some of the coating from the end of it. Okay, that's the coating off the end of it. Then what I'm going to do is I'm going to get a little tiny bit of flux. It's way too much flux. That is way too much flux. Way, way, way too much flux. So let's get our soldering iron again. Okay, I'm just going to tin the end of it with a bit of solder. Okay, done. Sorry, I was actually getting completely confused with myself there. This one here, actually, for those of you that know, trick question this was, or me covering my arse. This one actually doesn't go to that pin there, that one goes to there. Fortunately, they're only about 1/10 of a millimetre apart. So that's fine. See, some of us still do make mistakes even after this many years in the business. At least I haven't soldered it into place yet, because that would have been a big whoopsie. Bit of a kink in it there, just pull that kink out. Okay, now you'll notice on the camera view that it's probably a bit blurred at the moment. The reason for that is because it is actually blurred on my camera as well. Sometimes when you're microsoldering, you just haven't got time, or you're not able to correct for some blur that you might have in the image. You'd much prefer to carry on working first with the blur and then correct the blur later. So bend the end over here. There we go. That's all I'm trying to do, is just bend the end of that piece of wire over, so we've got more of a surface area for it to solder onto later. So that's that jumper almost in place. Obviously it's not going to hold perfectly until I've done the underfill, but it's kind of where it needs to be. That's what you go for first. So you get your jumper kind of where it needs to be. Then on the other side, I'm going to run the other jumper now. Okay. So this other jumper is going to have to go in over the other side. I might use tweezers for this one because I want to try and get I need to try and get this one on perfect. Okay, so again, okay, got a little tiny bit on the end. There's no flux here. It's not flowed. It's not flowed to the right location. So kind of having to do this bit without flux. There we go. It's flowed into the right bit now. So. That's a nice connection now. Now, I say do it without flux. You should never, ever, ever do microsoldering without any flux. It just will not work. I can't stress to you how much it will not work. It'll just fail every single time. You'll get dry joints, things will just keep falling off. It really is. Flux is one of the magic ingredients of microsoldering. So that's that jumper put into place now. So I used to use, talking about flux now, I used to use the MG Chemicals flux. I would get that regularly. I'd get a regular shipment of that. You know, quite a few tubes all the time. It was a big staple that I'd have to order in regularly. So I'd order in the MG Chemicals flux. You know, it's nice flux. I can't remember which number it is now. That was probably about a year ago I last used it. But MG Chemicals flux was my favourite flux back then. It's now overtaken by the Amtech flux. The reason I used MG Chemicals flux is because the MG Chemicals flux was one that I could guarantee. Just have a quick drink. It's one I could guarantee. I could always get a genuine tube of it. The Amtech stuff, you really struggle to get genuine tubes of this stuff. So I was really struggling to get a hold of good tubes of good flux. So it put me off. But then I managed to get a good supplier of me Amtech flux. and the flux is just so much smoother to go on. So I use the NC559 V2 TF. That's the stuff I use. Works really nice for me. So I'm just going to have to blow this flux away. Trying to clean this board up a little bit now. You'll notice I've just blown all those jumpers out of the way. It's okay, I know they're long enough. I know where they're going to go, but I want to get rid of some of this flux, because if I go and stick underfill over the top of all of this flux, it's not going to adhere very well. So what I want to do, get it all dried up a little bit, get it all defluxed, and then I'm gonna stick it down to the board. So there we go. You'll notice they've flown everywhere now. They're still attached, so that's fine. So we're gonna move this one back around, back into position again. You can see the board a lot better though now. So this board is now, you know, I've got rid of loads of flux off there, so it's really clear now, the image on the board. So in essence, the way I want it to be now is I want this jumper to go round and stop exactly there. See how it's just sticking up slightly? So what I'm going to do now is I'm going to get some solder mask. Okay, the way I do solder mask, I'll show you now, is I get, let's go back to camera 1. So I'll get a piece of paper like this. I'll get my solder mask tube, and I will inject a little tiny dab of solder mask onto there, and then that goes back away, and that little tiny dab of solder mask is what does the whole job for me. If you think how big that little tiny dab is in comparison to the board, that's why you need such a small amount. So on there, I'm just going to leave that to one side, show you on the microscope view again. So here we're going to dab it around the side here. Got a little bit in the wrong place there. Don't worry about it, it's not going to cause any harm. Okay, so now I've done that little bit. It's a little bit of a slow progress when you're doing it properly. So I've got that little bit on there, and I'm going to cure that now. A little tiny bit, I'm just going to cure that now for 30 seconds. Obviously it won't be fully cured, but it's going to be cured enough. So move that out of the way. You can see that's curing now. Still nobody in chat. Be really interesting to see if there is anyone connected to go on chat and say hello. There we go, that'll do for now. That's that little tiny bit cured. Go back to camera 3, microscope. Right, now let's carry on. So that's kind of glued down there. Let's get my tweezers again. We'll put a little bit more on. Really annoying when you can't get these jumpers to stay where you want. You don't want them shorting out either, that's a bad thing. There we go. A little tiny bit more along the edge here. So this solder mask's not a glue when you first put it on. Obviously it will hold things slightly, but it's not a glue. Well, as soon as you've cured it, it's a glue, obviously, but at the moment, obviously, it's not. So let's over to there, curing that little bit that I've done now. That'll do again. Okay, let's have another look at it. Right, that's looking good. Now it's quite well stuck over that area. I'm going to pull it over. There we go. I'm happy with that positioning. Yeah, that's nice, that. So I'm not going to cure that just yet because that's in position and it's holding itself there. I'm going to do this one as well now. So I'm going to pull that one down and round. Okay. If anyone's ever microsoldered before and they're just watching this for the fun of it, you'll realise quite how fucking small these connections are that I'm doing at the moment. They genuinely are tiny. It really is such intricate work getting this done. I can't believe it is actually so cheap, to be fair. I can't believe microsoldering has gone to be such a cheap thing. I suppose it's obviously you've got the value of phones. You can only charge a certain amount based on the value of the device. But really, you know, like this repair now, the amount of skill involved of doing this, the amount of years practice, and how cheap it has become. I understand why, you know, it's competition at the end of the day. People are willing to do it cheaper, so that's the way it works. If someone's willing to do it cheaper than someone else, so be it. It's the way it has to be. That's curing again there. But it's when people do things cheap, screw it up, and then it has to come to somebody else like me that's been in the industry longer, and then they're having to correct someone else's screw up. There's no regulation at all in the industry, so you know it's going to be like this for a long, long time. But that's how it is, that's how it is. You deal with the industry you're in. Right, so that's cured down. I have looked at diversifying and doing other things that aren't phone repairs, so things like ECU repairs on cars, other microsoldering repairs on other devices, just ordinary soldering repairs even. So, that's that bit. I need a tiny bit of flux now. Now I'm not going to inject the flux because there will be too much again. So I'm just going to put a tiny bit on the end of my tweezers. And I'm going to dab that tiny bit on the end of the wire that I need to tin. So that's the wire I need to tin. I need to tin that wire because I can't guarantee thorough adhesion of the solder from the component to the wire if I don't do this step. You can't say for sure, yes, that is going to connect straight away underneath the pad, because I can't see this when I'm doing it in a minute. We've got a good tinning on the end of that now. You see that? Okay, so what I'm going to do with that again is, let's have a little look on the microscope view. You can see what I've just done there. I've tinned the end of that wire. I'm just going to coil it round like I've done with the other one. Give us a bit more surface area to connect to. It's not strictly needed to do this coiling bit, it's just what I do. You could just stick the piece of wire under there, do it, so be it, done. But this is just my personal method. I will always, where possible, attempt to create a coil underneath. Okay, so now you can see here we've got the 3 wires that we would have had originally. We want them to be as smushed down as possible because we want it to get connectivity to that pad as well, you see. Okay, so that to me looks fine. All I want to do now is just check that I haven't made any silly mistakes now before I go and solder the component on in a minute. So I'm just going to check now just to make sure that none of this is shorting out now. So I've got, doesn't really matter which side, I want to make sure that that's still open. Yeah. Is it connected to any of these? It's not connected to there, it's not connected to there, it's not connected to here. This one here that we've run this jumper, let's make sure that's not shorted out to there. No, it's not. So we're okay now. That pin there, no, we're okay. So we're all right. I like to check that, make sure that nothing's shorted while I've been running those jumpers. If it has, obviously, you're not going to have a good time when you go to put the component on. Right, next bit. How long are we on this stream for now? We've got 32 minutes on it so far. So I'm going to get the component now to go on. So these are the gas gauge components. Focus. This is a whole ribbon of them. Get these in bulk, order them a couple of hundred at a time, because we also sell them online as well for people that want to do this repair themselves. Yeah, some people still do want to do it themselves. So I'm just going to get one of these now, and I'm going to put this out on top of, where are we going to put it? I usually put it on top of the battery and do it there, but we'll put it on the housing. I'll put it on the board here, actually. There we go. Right, so let me just show you that component now. So where is the board? There it is. Can we all see that little tiny component? So that one is the MOSFET which handles the gas gauge. So what I'm going to do with it is those little pads there need a little blob of solder each going on top of them. So what I'm going to do is get my tweezers hither. I've got a little bit of flux on top of the tip of this other set of tweezers, and that flux is just gonna, there we are. Little bit of flux there. Now what I'm going to do is I'm going to get my soldering iron, and we're going to put a little dab of solder on each of those pads. Okay. Is we there? Yep, we've got a little dab of solder on each of those pads now. So we put that little dab of solder on because there's no solder actually on the there's no solder on these wires here. So if we go and try and put these components straight in, without any solder, then it's not really going to work properly. So we've tinned. It doesn't look very nice at the moment, but don't worry about it. So basically we've put a dab of solder on the top of each of the 3 pads, and now what we're going to do is turn this component over into position, and it's going to go on top of them. Just move that wire slightly, move it slightly back. There we are. Right, so I'm going to use quite a low temperature here. I'm going to go in at about 300 on this one, mainly because I've switched everything here now to leaded solder, so the temperature for it melting should be a lot lower. And also I've got a lot of other components around. I don't want to float them, don't want to cause any issues. So there's the components. We're going to go in now and we're going to heat up. I'm going to put the component onto the board. Hold on. Okay, that's slightly connected. I've seen it melt on one of the pins. We're just going to do it on the rest of them now. I'm going to hold it down in place now because if I don't hold it, it will blow away. How are we doing? So that one's on. Just want to check that other pin that's holding it to the board. Want to make sure that's melted. So let's go back, pull the scope back, and I'm going to look at it at an angle. Looks like that's connected. That's connected. We've not got an amazingly good angle on that. So it's slightly out of position. I mean, as long as it's connected to the board, it doesn't hugely matter whether it's slightly at a squiff or whether it's perfectly straight. Let's measure that circuit now. Let's go diode mode. I want to check that the end pin is done. Okay, so we're getting the correct reading off there now. Now your readings are going to go slightly down on this. This is 705, 708. The reason it's gone down is because of the heat. So we've got heat on the board and it changes the resistance of these circuits. So that is now showing the correct reading for that circuit. Okay. That's showing the correct reading for that circuit. Okay, so that now looks like that's actually worked and correct. I want to just make sure that it's properly adhered. I am going to give it a slight nudge because I want to make sure it doesn't just move easily. See, it has got a slight wobble on it because it's only attached to that board by one pin. So basically that whole component is attached to the board by one pin at the moment, which isn't great. You know, it's not how it should be. Like this one doesn't wobble at all, right? So that's cool. Now what we're going to do, we're going to use our underfill again, and we're going to stick this down to the board a little bit more with a tiny bit more underfill, because obviously it is only held into place with that one pad. We want it to have a bit more structural rigidity, so we're going to add some underfill here and a little dab over here. Okay. So this is going to give this chip the rigidity that it had originally when it had 3 pads holding it down. So there we go, you can see that there now. That's the finished. Let's do that and get a nice little, we can use that as the snapshot video. Get that focused. There we are. I'll probably use that as the intro snapshot for the clip, for the video. So now I'm going to use UV lamp again. I'm going to cure it now for a minute, and then that should be the repair done then. So we've ran 2 jumpers. It has taken a bit longer than I wanted. This repair would usually take, without me sitting chatting about it, will probably take about 15 minutes. It's taken 42 minutes now. But you know, I feel I've had a chance to explain it properly to you, how it's all done. Cure that again, because it was quite a thick bit, that area was. So yeah, very interesting repair, this one, and it's got a good success rate. If you're doing microsoldering yourself, you should have 2 types of repairs. You should have your routine repairs, which are the ones that you bread and butter. You can get them in and out in a known amount of time. And then you've got your other repairs that come along, which are obviously non-routine. So those types of repairs are going to be the ones where someone's sent you a description and explaining the symptoms, and how it's happening. And then you'll basically try and diagnose all the way through what the problem is. This phone's just got a screw that's just fallen out of the volume. Volume mute switch. The screw's just fallen out of it. I don't think that's actually the correct screw for it. That's why it's fallen out. Someone had definitely been in this phone before me. Yeah, it's not supposed to go there. I'll have to let the customer know on that one. So basically, I'm just going to put this board back in again now. Sorry, not board in, the screen on. And then that should be the repair done. So if I just switch over to there for a second, I'm just going to jig this camera over so you can see. Okay. Right, show you now. There we are. I'll switch back over to camera 1. Right, so you can see here, there's the board that I've just been looking at. That's my phone, that can go over there. Right, I'm going to put this battery back into place. It wasn't connected to the board to begin with, sorry, it wasn't glued in to begin with. So it's literally just slotting in at the moment. So I don't like to even stick things back in again when people send them, because sometimes this might not even be the chassis for this phone. People like to do all sorts of things, so I don't like to assume what they want to do with these devices afterwards. So that's that going on. That's the battery in. See if we can power it up now. That's it, powering up. Obviously, if there is customer data, I don't want that to be seen. So I'm just going to plug the power in here. We can see it's now pulling 1.5 amps. There we are. So you can see on there, if I unplug this, done. Now you've got 46%, 45% charged. That's it. Thanks very much for joining me. Please have a look on www.bitrepairs.com and like, subscribe. Thank you very much, and I'll hopefully see you for the next video. See you soon.